All right, what I'd like to talk to you now is really about a special case of the non-inverting amplifier, which is called a voltage follower. All right, here is our non-inverting amplifier, and of course the closed loop gain of this is really R2 over R1 plus 1, and the input resistance is AV open loop times Ri divided by AV closed loop. This is the configuration for the voltage follower. Here we've got the output now that's connected directly back to that inverting input. And then of course we've got our signal that's connected to the non-inverting input. Well, how is this different from this? Well, look at this connection between output to the inverting input. Have a look at that connection. All right, well, R2 effectively has become what? It's a short, it's effectively become 0. So we can say R2 really has become a 0. All right, well, what about R1? R1 was basically connecting from this point to ground. Well, the R1 has effectively become what? An infinite resistance. So we can say R1 has become infinity. All right, now, how does this relate to the closed loop gain and the input resistance? So let's put this information into those two equations and see what we actually get. Well, all right, V out then over Vs would be equal to, well, the R2 over here has become 0. So that's 0 divided by infinity. So let's just put that in. That's a 0 divided by infinity, which is the R1, plus 1. And so really, what has happened here, this V out over Vs has really become just equal to a 1, hasn't it? So the closed loop voltage gain, so AV closed loop in this case, really is just a 1. What about the input resistance? Well, that's AVOL times Ri divided by that closed loop gain. And so therefore, that input resistance then would simply be equal to the open loop voltage gain multiplied by Ri, and it's divided, of course, by 1. Okay? So we may ask the question now, this is an amplifier then that's got a very, very large input resistance, which is, of course, the open loop gain times Ri. And in the case of 741, remember Ri was about, what, 2 megohms. This is about 200,000, so this is what? It's about 200,000 times 2 megohms, very, very large, but it's got a gain of 1. So the output is really the same as the input. And so we could ask the question, how would we use this guy? All right, let's have a look at this little example over here. What we've got here is a 100 millivolt source. Okay, we've got a basic resistor combination here, 1K sitting here and a 1K over here. It's connected to ground, and then we're feeding this into an inverting amplifier. So we've got a 1K sitting here and a 10K sitting over here. Now look, the question that we might ask first of all is, what is the voltage at this point here? I might label that. I'll call that, for example, just V1. What is that voltage that we're actually seeing there at V1? Well, given that this is an inverting amplifier and it has basically an input resistance that's looking in at this point equal to this, what was the R1 resistor, which is 1K, that's a 1K input resistance that really is connecting to this 1K of this circuit over here. So this 1K here is effectively being loaded down by this inverting amplifier configuration. Okay, so this 1K then appears in parallel with the input resistance of my inverting amplifier. So that voltage there, V1, would be what? Well, you'd work out the parallel combination of these two 1K resistors, which is what? 1K in parallel with 1K is 500 ohms. Okay, so we'd basically have 500 ohms for that parallel combination. We're trying to work out that voltage there. So this is an equivalent now of 500 ohms, taking into account that input resistance. And it's potentially voltage dividing that 100 millivolts. So it's really 500 divided by this 500 in conjunction with that 1K, so that's 500 plus 1K, and that is multiplied by that 100 millivolts, and that is equal to my V1 voltage. So therefore, my V1 voltage then would be equal to, what is that? That's really 500 over 1.5 times 100. That is actually equal to 33 millivolts. Okay, so it's 33 millivolts at this point right here. Well, then that is fed into my inverting amplifier. My inverting amplifier will have a gain of what? The R2 over the R1 with a minus sign. And so therefore I could say my V out in this particular case is going to be what? It's going to be a minus. We've got our 10K divided by the 1K multiplied by this voltage here, which is 33 millivolts. And I've got a gain of what? 10 times 33 millivolts, which gives me basically a gain of minus, or an output voltage I should say, of minus 330 millivolts. So in this particular case then, with this circuit, that inverting amplifier was effectively applying a load to that circuit and therefore affecting what that V1 voltage is. All right, so here we have basically that same circuit that we had before. We have our inverting amplifier, we had before too, but we have a voltage follower that's in between these two, okay? So we want to see what this voltage over here is, then what is this voltage here, and what is the output voltage. All right, let's think about this. Looking into our voltage follower, what do we have by way of an input resistance? Look, to all intents and purposes, that input resistance, even in a practical sense, is so very, very large, we can assume it to be infinite, okay, especially in relation to this 1K. And so therefore, there is no loading as a result of putting that voltage follower in that position. And so therefore, we've got two 1K resistors there. This is a voltage division of that 100 millivolts. So it's 1K over the sum of the two. So it's 1K over 2K times 100 millivolts, which means that this voltage right here is actually 50 millivolts. Okay, 50 millivolts feeding into a voltage follower, which has a gain of 1, means that on this side over here, we also have 50 millivolts. Okay, now 50 millivolts then feeding into my inverting amplifier, what do I have? My output voltage then is simply going to be equal to a minus, what is it, 10K divided by 1K multiplied by the input that we see over here, which is 50 millivolts, okay? So really we have what, 10 times that 50 millivolts, and so therefore we have an output voltage which is really what, 500 millivolts. So this voltage follower basically has acted what? It's acted as really a buffer between my inverting amplifier in this case and this little potential divider circuit over here. And that's one big application really for voltage followers, is that they're used as buffers.